today we're going to be looking at the basic building blocks of geometry. So this is a very introductory course, usually around 5th or 6th grade. So if you're a high school student, this is a good thing to reflect back on, just to kind of learn the terminology. If you're an elementary student or parent for that matter, you could also take a look at this just to look ahead. I have some good techniques to remember what is a ray versus a line versus a line segment, all those things. It's pretty straightforward, but it definitely will be crucial for when you're moving forward into your more advanced geometry type of work. So take a look at it. It should not be a very long video, only because, like I said, it's very basic, but otherwise also important. So please make sure you're subscribing, liking, commenting. All that will help me out. Otherwise, enjoy. All right, so let's talk about some of the things that we would see in geometry as intro. Some of your basic types of figures or shapes, I guess you could say. So the first thing is what we have is a point. So a point would be an exact location in space. All right, so if you think about a real world situation, like if you're looking at a GPS and you're pinning where you're at, that would be the point. So points are, in my opinion, I would call it one-dimensional types of shapes. And then the next thing we see is what's called a line segment. And a line segment is part of a line or array that has the definitive beginning and end. So you could call it part of a line. All right, so another real world analogy would be, I'm going from, in a straight line, I'm going from my house to my neighbor's house directly across the street, which would be a definitive beginning, a definitive end. All right, so this is called a line segment, all right, which is easily confused with what we see next, which is called a line. All right, where a line has goes on in opposite directions infinitely. All right, so that means that the lines will continue on forever. Like, so if you think of a number line going negatively, it's going to go on forever. There's an infinite amount of solutions or possibilities, and then positively it can go in the other direction infinitely as well. The next one is what we call array. So if you look at array, array is kind of a mix between a line segment and a line. So array has a definite beginning, I guess you could say, and goes on infinitely in another direction. And the easiest way to remember this in terms of real world terms is think of the sun. The sun has rays coming off of it that go out in all these directions infinitely. All right, and then the last one is a plane. All right, not to be confused with a plane that is that you fly in, but a plane is something like a flat surface. So if you think about a coordinate plane, it's flat. All right, so sometimes think of like a desk. So a plane is a flat surface that has no thickness and extends forever. All right, you see this a lot with graphic design, things like that. All right, so let's look at how these are labeled or plotted out, I guess you could say. So the first thing they're asking us is to identify 3 points. So the points in non-math terms is your dots. So the way you would write this is just, you could say D, E, and F. There's no geometric way to label these. And then if they're asking us to write 2 lines, well, we got to make sure that the arrows are continuing through. So we could go a couple different ways here. The symbols for lines look exactly like what we're talking about. So we could say DE. We could also say, you could have also said ED. It doesn't really matter the order for this, at least. You could also say DF. All right, you could also said FD. What you can't say is EF because they are not connected. All right, so that is not a straight line. There's a little bit of a kink in the road there. And the line segment, a line segment is part of a line, so you really could say the same thing. So the difference is that it's drawn without the arrowheads. All right, so they're only asking for one, but we could list all of them. All right, so similar to what we had before. All right, and then a plane, there is no geometric symbol for that, but I always tell students to write the word plane and then to pick any 3 points that are within this plane or within this box. So we're just going to go D, E, F, and you don't need to separate them by commas. All right, and then the last one, array, you have a starting point, and then it needs to continue off infinitely. So we could go from D to F, we could go from F to D, we could also go from D to E, and then we could also go from E to D. All right, notice that E and F are not used because those are not rays. All right, this image is a little bit different than what we had before. Makes it interesting. So we have 3 rays. All right, so we always want to name the endpoint first, where we're going to start. So we could do M to O, but we could not do O to M because this line does not continue through the M, it stops, so that we could not do O to M. We could do M to N, and then we could also do N to M, because we have these arrowheads here indicating that they go off. Where here we do not. It does not do that. Okay? And then if we look at 2 line segments, I believe that there is more than 2. Remember, the line segment is drawn like that, no arrowheads. We could say M to O. We could say M to N. And then we could also do the reverse of that, O to M if you wanted to, and then M to N. All right, and then the last thing we're going to talk about is congruency. So when things are congruent, they have the same shape, same size. So think of it like a carbon copy, or if you're copying and pasting an image that's exactly alike from the original. So if we look here, we have these little hash marks. It almost looks like it's barbed wire. They want us to identify the line segments that are congruent. So the shape is, if it's a closed figure, these are all line segments. Nothing goes on infinitely. Well, if we look at A to B, right, I can highlight this, A to B right here. So we have line segment A to B, and then the symbol for congruency looks like this. Well, that is similar to CD, right? Okay, the next one we could have is if we go AC, line segment AC, well, that's congruent to BD. All right, and the tick marks that we have here, the first one had 1, the second one has 2. That helps us out, gives us some guidance. All right, and then we have some other sets, right? Now, we have the ones with the thirds, or with 3 hash marks. We have AE. Well, that's also similar to BF. Which is also similar to DF, or congruent, I should say, which is also congruent to CE. All right, so this can happen, okay? We can have multiple types of line segments that are congruent.